nth terms of the two series are given and they are equal. We'll find the value of n. So, could you get this?
Yes, sir. So there are two series. So the first one and the second one, we can take it separately.
Okay.
So in the first one, the first term is 3 and the difference is 7.
First term is 3 and difference is 7. Yes. So I'll write A1 to mention that first series. Okay. So A1 is 3 and say D1. A1 doesn't mean only the first term of the first sequence. Okay. And D1 is 7, right? Okay. Yes.
And now we apply the formula of an equal a plus n minus 1d.
Okay, an. Just to mention, I'll write an1. Okay, just to say that it's from the first sequence. So it is a plus n minus 1 into ds. So this means that it is 3 plus n minus 1 into 7. Or just to simplify, 7n minus 7 plus 3, which is minus 4. Right? Okay. What?
Now we can do the same for the other sequence.
Okay, same for the other sequence. So it is 63, 65, 67, so on. So in the second sequence, so this is A1 only. A means the first term, not the second term. Okay. So the first term is 3, and the common difference of the second sequence is 2. We are applying the same thing, A and 2. So for the second sequence, we are trying to find the general term. So it is A plus n minus 1 into D again. So A is 63 and n minus 1 into 2. So to simplify, it's 2n minus 2 plus 63. So it is plus 61. Okay.
Now we can solve the simultaneous equations.
Yeah. Simultaneous. Yeah. They're equal, it's given. No? We can directly equate it and need not do anything else. Right? So they said that these two equations or these two terms are equal. Right? So I'm just going to equate these two. So it is 7n minus 4 is equal to 2n plus 61. So if I just equate, 5n is equal to 65 or n is 13. Right? That's the solution. Chat is not visible. Just okay. So the same answers are put. I hope it's clear, no doubts, right? Okay. Next one. Let's see somebody else. Pranav, can you tell me? Have you got this?
Yes, sir. We can write 15 is equal to A1 plus D, 8 minus 1.
Okay. So 8th term of an AP is 15. So we are using that. T8 is 15. That's what we equate. A plus 8 minus 1 into D. Yes.
Or we can write 15 is equal to 7D plus A1.
S15 you mean? S15.
Yes, sir.
S15 is actually what? I'll write the formula for Sn. It's n by 2 into 2a plus n minus 1 into d. Right? So for 15, it's 15 by 2 into 2a plus 15 minus 1, which is 14d. Fine?
Yes, sir. Then we can take 2 common, and it's a plus 7d.
Okay. So this is a plus 7d here. So here, if I take 2 common, so this is by 2. This is 2 times a plus 7d. Okay. We already know what is a plus 7d, isn't it? Yeah. So we'll simply substitute. This 2 will get cancelled. So it's 15 times a plus 7d. A plus 7d is 15. We already have searched and got the answer for a plus 7d. So it's 225. Right? Okay. Next one. Yes. S1 is 1, S2 is 2 and 3, S3 is 4, 5, and 6. S4, so on. Then the first term of S20. So somewhat we're writing down some patterns, right? We're trying to figure out what should be S20. Okay, let's see. Yes, Asutosh, you can tell me.
Yes, sir. So the uh, I just added the first 19 terms and plus like the first term of S3 will be 1 plus 2 plus 1. The first term of S4 will be 1 plus 2 plus 3 plus 1. So using that pattern, the first term of S20 is the sum of first 19 numbers plus 1.
Okay, okay. I'm trying to figure out what your pattern is. So you're saying 2 is 1 plus 1, right? So
Yes, sir.
4 is 2 plus 1 plus 1. Is that what you're saying?
No, sir. The first term for S3 will be 1 plus 2 plus 1.
1 plus 2 plus 1. That's what? What is that plus 1?
That's just to
Just a
get the
number.
next term.
Okay, okay, fine. How do we get 7? How do we get 7?
1 plus 2 plus 3 plus 1.
Oh, 1, okay. It doesn't depend on these numbers at all. Random. 1 plus 2 plus 3, 7. Okay, okay.
No, the numbers preceding the sum.
Oh,
Like
the number
S4
of
will be.
numbers you mean? Huh? Number of numbers. That's
Yes,
why.
sir.
Okay, okay, okay. So that was the pattern. Look at this. So there, see, what are these numbers? See, if there are 10 numbers before, this would be 11, isn't it? That's it. Correct. There's no other. That's the pattern. That's all we have to figure out. So, for example, why is this 4? Because 1, 2, 3 are done. Right? So, this is 7 because this is 1, 2, 3, 4, 5, 6. Next number is 7. That's all. Now, how do we get 7? Look at this. The S1 will have one number. S2 will have two numbers. S3 will have three numbers. Right? If you add them, you should get the next number, isn't it? How many numbers are there? Because it's continuous numbers. If there were a gap, probably we would have to use something else, right? You would have to multiply with something or something like that. But here these are just numbers. These are just counting numbers. So how many numbers are there? That should give me the count, right? For example, to get 7, there is 1 here. There are two numbers here, 3. So total 6 numbers are over. So the next number will be 6 plus 1, isn't it? That's all he's saying. Okay. Now he's saying, looking at the same pattern, for example, S5, we'll just try to figure out S5. S5, that means S1 had one numbers, S2 had two numbers, S3 had three numbers, S4 had four numbers. S5, this is the number I want. So I'll add one number to the previous. So the sum here is 10 and plus 1 is 11. You can see that S5 next should be 11, right? Right? So the same logic he extended to S20. He's saying that this sum will be equal to 1 plus 2 plus 3. It's not the sum. The S20 is first term. We want the first term of S20, right? So the first term of S20 would be this sum up to 19 plus 1. Now we already know how to find the sum of first n natural numbers. So it's 19 into 20 divided by 2 plus 1. So this would be 10. So it's 190 plus 1, 190. Right? Right? You can probably find for Sn only. Right? What is the first term of Sn? We did not do. Because we already know that. How many terms are there, right? So it will be 1 plus 2 plus 3 up to n minus 1 plus 1. Isn't it? It's fixed. So this would be what? N minus 1 into n, because the same formula, n into n plus 1 by 2. So divided by 2 plus 1. This would be the first term of Sn, right? Right? I hope it's clear. So this is a sort of your GMAT problem itself. Obviously we are using something called as arithmetic progression here, but without that also probably you could figure out by writing down the patterns, right? Okay. But if it's more involved or the common differences are different, something like that, then clearly you would have used formulas for AP. Okay. Similarly, again, I think you have to figure out the pattern, right, and try to get it. Karthik,
Yes, sir.
can you tell me, did you get the answer for this one?
Yes, sir.
Tell me, what should we
I
do?
got it as 17.
Yeah, we'll see whether 17 is right. It's okay. Tell me what can be done and how do we figure out what is the answer?
So the same thing as the previous one.
Okay. So
Yeah.
so yeah, can you put it down mathematically?
So first term is 1 and next 2 terms are 2, next 3 terms are 3, next 4 terms are 4. So it
Okay.
goes on like that.
Okay. So
Um,
what?
so I can't remember what I did actually.
Yeah, just look at what you have written down and figure out. Written down something correct.
Yeah, so I added those terms 1 plus 2
Till
plus
where did you add? Till where did
Yeah.
you add?
I think I did it till
Yeah.
150, I guess. No, I took it as n.
You took it as n. Okay. Then
Then I took this first 10 terms, sum of first 10 terms.
okay, we stop here and we take sum of first 10 terms. That's what you're saying?
Yeah.
Okay. Sum of first n terms. Okay, n terms. I mean, I assume it's 10. Okay, so it's sum of n terms is n into n plus 1 by 2. Okay.
Yeah. Equals to 150.
Why should this be equal to 150?
Oh, wait. Oh,
You may be right, but I just want to know why.
yeah, because we are finding 150th term.
Okay. So does this sum convey the same message? Like, does this sum tell you that 150th term should be equal to n into n plus 1 by 2?
I don't know what I was thinking at that time, but I did it somehow.
It actually conveys the same thing, but you should give me some justification for it, right? Why does it convey? So that the people who couldn't get the answer, probably they also can think in similar line. He's saying that this should be equal, but we don't have a anybody else who can give a justification.
So, when we continue and solve this equation,
Yeah.
when we try to solve the quadratic, we don't get an integer for n. So, I didn't go to solve completely, but we get something little more than 16. So we floor it to 16, and then we get it somewhat a little less than 150, that is 136. So the
Yeah.
next number is this one.
Okay, I get your point. You're saying when you try to solve this, you don't exactly get a value, proper integer.
Yes, sir.
So you're saying it's little less than 16, little more than 16, little less than 17 or something like that, you're saying, right? That's fine. That's not my concern right now. My concern is why are we equating this to 150? What is the pattern? So you're saying why are we adding these numbers?
There's the number of numbers. It is 1 and then 2 2s and 3 3s. That's why.
Okay. So at the end, so when I go to n, does this give me the nth term or something?
It will be the number of n's. N will be the
Number of n. So somewhat this would be the starting point, right? Starting point, right? Maybe something like that. See, let me just try to figure out. It's fine. In this problem, maybe you get the answer by inspection or something, or the number is smaller, right? Probably I go for a huge number or something. Are you sure that sum will be the same? That's all. See, just for example, so if I'm talking about this number 3, what exactly is this giving me? So after this, it's saying that okay, this is 6 numbers. That's what you're saying.
Sure.
Now, for example, you got n to be between 16 and 70, isn't it? So what is the answer? 16 or 17?
17.
Why 17?
Because we get a little more than 16. So when we take 16, it will be less than, it will end in the 136th term. So it will be 16 times that will end at the 136th term. And then at the 137th, 17 will start.
Okay. So n is a number where it starts or something. That's what is n. That's what my question was. What is this?
N is a number that ends.
Ends, right? So if it ends, her justification says that it should be 17. By that logic, it is 16 point something. Okay. So it should go to the next number. Okay, fine, makes sense. So that's what I'm saying is, see, for this particular problem, maybe it's not that involved, right? So whenever you're writing, or for example, you're writing a subjective answer, maybe, right? So you can just justify what is n, because I know, because the solution needs this, right? You're writing the equations fine, but it will help you write a better solution. Okay. So for example, yes, so if you say that it's ending, so to count the first 6 terms, this is how I'm counting or something like that, right? So when I'm saying n, yeah, this may not be 150. Why am I equating to 150? Right? I'm not sure, right? So it might end above 150 also. Okay, something like that. Right? It's okay. So we try to solve this. This is what you're saying. So n into n plus 1, two consecutive numbers should be equal to 300, right? So because you said 16 and 17, if you want, we can solve using quadratic equations.
We look for a square. Yeah, the square is easier.
What way? If
the numbers are too close, then we see the square. It is
yeah. We see where the square is. So what? 289, right? 17 square, correct? So this number would be, if I take n equal to 17, 17 into 18, right? We just have to see whether it's crossing 300 or not, right? Does it cross 300?
Yes, sir. It comes as 306.
306? Is it 306?
Yes, sir.
Okay, so it crosses. And then obviously, if I take 16, then it's 16 into 17. This will be less than 300, right? For sure. Okay. Now, what I got, so some n is there in between 16 and 17, which satisfies this equation. Right? That's what we are getting. Okay. We don't know, it's not an integer. Okay. So we are saying that this n ends, right? Ends here. So we're getting 16 point something. So if it ends, whatever this, let's see what is 16 into 17. 16 into 17 is what? 42. Right. So this is 1. So this is 30. Right. This is 252. That's
270.
Is it 252?
270.
272, sir.
270. Oh, sorry. Okay. 3 plus 4. Yeah. 272. Now, look at this. We are saying that 270, it ends at. So if I use 16, that means 272, it ends, 16 ends here, and then 17 starts, right? 17 starts and goes up to where? Up to 306, up to 30. Sorry, the terms are different. We are not written down the terms properly. Okay. But the term should be 150, the half of these numbers. We just try to solve here. Okay, that is my mistake.
The 270 by 2 is there.
Yeah. Both are divided by 2. The terms are divided by 2. For example, this would be, say, 136, and this would be 153. So 16 actually, 17 starts from 137. So up to here it's 16, then it's 17, then it goes up to 153. Right? It goes up to 150. So 150th term will be one of these 17s. That's how you figure it out. Okay. So could you repeat why n into n plus 1 is equal to 150? So this is not exactly, see, what we know. Suppose it ends at 150, it would have been great. This would be a perfect solution. Okay. Suppose this term, for example, this n, this 4, right? If it ends and the last term was 150, we would have got the perfect solution by using this equation. Now we are not getting that solution. We're just trying to make an estimate what is true. Fine. Is it clear, Swasti?
Yes, sir. Thank you, sir.
Yes. Right. It's clear for others also. Any doubts here? Because I don't know. See, this problem on the previous was almost similar, right? But yeah, writing down things probably you have to figure out. Okay. Yes, Ganesh, can you?
Sir,
Yes. Yes.
what I did is the coefficient of x power 99 is actually the negative of the sum of the roots of the product.
Oh, is it? Okay, okay. So you're saying coefficient of x power 99 is negative of the sum of the roots of the product. Okay. How do we know this? Do we know this?
In algebra, we learned
Okay. So you've done for any x power n polynomial. I know we have done for quadratic and for this one, I think. But for any nth degree polynomial also, it's true. Okay. Okay. So what is this sum? Tell me then. So what is it equal to?
it is going to be negative of -1 plus -2 and so on till -100. Then you can be 1 plus 2 plus 3 plus 4 so on till 100.
Okay. So minus 100. So just multiplying the negative side inside.
So it will
So
become 1 plus 2 plus
1
3.
plus 2 plus 3 plus 4 plus 5 up to 100. Great.
Then you
So
can use n into n plus 1 by 2.
yes, 100 into 101 by 2, which is 5050. Okay. So I don't know if everybody knows this concept. It's fine. We'll try to approach this in a different way also. Right? So he's saying, if this is a polynomial, now there are factors given, right? If I write it in a polynomial, so this is 100 terms. So you'll have something like a into x power 100 plus b into x power 99 plus c into x power say 98. Okay. I don't know whether he has taken into account. He says that the coefficient of x power 99, which is 1 less than x power n. In this case, it is x power 100. Okay. So that is nothing but sum of the roots. Sum of the roots, okay, is equal to minus b by a. We have seen this, right? In a quadratic, we have seen the same applies to cubic. Same applies to nth degree polynomial. Right? So that is the logic. He didn't say divided by a and all, right? But that, see, in this case it is 1, so it didn't make a
B
difference.
is 1, that's it.
Yeah. It didn't make a difference, but in general you have to write a. Okay. There's some other factor to be a. Okay. Anyways, suppose I didn't know this concept. Fine. I don't know what is this roots, all these things. But still, why is a 1? Just multiply and see, no? X power 100, what do you think the coefficient can be? If everything is x, can you think there can be something else with x? No, right? X power 100 only. Okay. Okay. If we don't know that concept, okay, we don't know what is this roots, and roots only come when you equate it to 0. So I don't know that, but what else can be done? Any direct approaches? Anyone? Yes. How did you do, Siri? What was the approach? Same?
I did not complete the problem, but I just started taking the first two terms and I multiplied and
Okay, just tell me what you have done. We will try the same approach. Then we'll see if you can extend your same logic, right? Then what do you do?
yes, sir. So I just took the first two terms and then
Okay, first two terms you did took. Okay, well, you multiplied these two.
yeah, I expanded.
So okay, so it's x square plus 3x plus 2, correct?
Yeah. So here the highest degree is x power 100. So they're asking about x power 99. So I thought
Okay.
I'll notice some pattern. So
Okay. So did you multiply the next term also?
yeah, and then I saw the coefficient for x power 2.
Okay, let me say, see, we have multiplied these two terms. So I'll multiply and see.
No, sir. First, I considered the first quadratic equation. There,
Okay.
x power 2 is the degree.
Yeah.
So I saw the coefficient of x to the power 1, which is 3 there.
Okay. Yeah.
And then
Yeah. So
and then
in
I
that
1 plus
experiment,
2,
we got x
3.
square was the power, x coefficient was 3. That's what we get.
Yeah. And then I considered 3 terms, x plus
Yeah.
3 also.
So again, you multiplied, right? The 3 terms.
Yeah.
That's what I'm trying to do. I'm trying to multiply now. Okay.
Yes.
So instead of multiplying again, so we have already figured out this one. I'll simply multiply it with x plus 2, isn't it?
Yes.
Fine. So I'll multiply. So this is x cube. So to get x square term, this is one of the x square term, this is the other x square term, right? So 3x square plus 3x square. So it's 6x square. Fine.
Yes.
Next is what? So x term. So 3, this is 9x, 2x, this is 11x, right? Plus 6. Fine.
Yeah. Here I considered the coefficient of x square because it was 1 less than power 3.
Okay, so you've seen x square. So this is 6. Okay. Okay.
Yeah.
Did you continue the same?
No, I did only till here. I didn't check if the pattern continued, but I thought it would be like 1 plus 2 will be 3. And then
Okay.
1 plus 2 plus 3 will be 6. I didn't continue that.
Okay. But still, that is very vague right now, right? To just assume that the pattern will continue, right? There's nothing definite connecting all those things. Okay. But just forget about this for 1 second. Think about the product of this 100 terms. Can you tell me 100 terms? When will I get x power 100? When do I get x power 100? If you just imagine the multiplication of all these 100 terms right now together, when do you get x power 100?
When all the x's are multiplied.
When we multiply all x, correct? So when do we get x power 99?
First 99 terms.
Yes, yes. Sorry, I couldn't follow.
99 terms.
99 terms. So 99x I should choose, correct? Rest one can be a number. That's when I get x power 99, isn't it? See, we are multiplying all the terms. See, if I multiply all x, I'm going to get x power 100. There's no doubt, right? That is one of the terms. What are the other terms? Instead of multiplying all x, I'll multiply all x. And the last time I'll choose this number, right? First, there are 99x, correct? But instead of that, their last number I chose, so it's x power 99. So one of the terms is 100 and x power 99. Is it clear? Right? But instead of choosing this number, I can choose any number, right? I can choose this number and rest all x. So one of the numbers is x power 99 also. Isn't it? Now again, you can think in a similar way. Instead of choosing 1, I could have chosen 2 and rest is x again. Again, see, multiplication means I'm going to multiply each and every term. That is multiplication. There's no term that is going to be missed out, right? You're multiplying 3 terms, you multiply each and every term, right? So you get 8 terms at the end. Right? Similarly, so you can see that, yes, if I take 2 numbers and rest x, I'm going to get 2 into x power 99. Similarly, if you continue with the same logic, you can see that each of the numbers should be there. So what do you get? 1 plus 2 plus 3 up to 100, right? Into x power 99, isn't it? So that should be the coefficient of 99. There can't be any other number, right? You have to get 99x and you have to get one number, isn't it? So this is the only way you're going to get this. So the coefficient is 100 into 101 by 2. Fine? Clear? Okay. Instead of 99, I asked x power 98. Right? So try to find the coefficient of x power 98. More involved than x power 99, but you can try to figure out.
So will so we have to multiply x 98 times and then two constants. So the number will add up to 1 into 2 plus 2 into 3 plus 3 into 4 plus 4 into 5 plus 5 into 6 plus so like that until 99 into 100 plus 100 into 1.
Okay. Okay. Fine. Do we know how to find this one? And is the, what terms you have said, is it complete? Those are my two doubts here. what pattern he said, is it complete? And do you have a method to come find out what the sum is?
I'm not sure.
You can think of, it's okay. This would be a CET level problem, right, in 11th standard on binomial theorem. So finding out the but there are different techniques you would learn by them. But it's not that you can't figure out using this one.
Sir, what I said at first, I don't think that is correct because there will be many more terms.
Yeah. So what is the pattern? Tell me. Let's figure it. So what do you think?
So yeah, when we like choose two terms, the possibilities are like when you choose, you can choose 1 and 2, then 1 and 3, 1 and 4, 1 and 5.
So see, again, the logic is same. We are choosing say 98x, right, out of those, and rest two should be numbers. So first you can, yes, 1 and 2 can be the numbers, rest all are x. Then you can figure out, okay, I can choose this x and choose 1 and 3. Yes, 1 and 3 also can be. It's not only 1 into 2, then 2 into 3, then 3 into. That's not a pattern. You have to figure out, when I multiply this, can I get some other numbers? Yes, we can. So then what? Then we have, say, 1 into 4. Similarly, this doesn't end here. Then again, you can have 2 into 3, so on. Then 3 into 4, all those numbers. So again, 3 into 100, so on. So it will continue again up to 99 into 100, however you want to write the pattern. So there are a lot of numbers here. Thinking about writing the sum of all these numbers. Anybody has a method? Sum of all the different possibilities here. Anyone has a method?
Sir, I thought first we could consider multiplying 1 with other numbers, like 1 into 2, 1 into 2, all the way to 1 into 100.
Yeah. So you mean 1 into 3 plus 1 into 4, all those things, up to 1 into 100. This is what you want me to find first, right?
Yes, and then with 2, and then we can take 2 in common.
But 2 is not starting from 1, no?
2 starts from 3.
B, right? Do you get the idea?
Then we can take 2 common. Then we
Yeah.
add.
Yeah, we can take 2 common. Then the first we can take 1 common. So this will be 3 plus 4 plus 5. But you can see that it's getting tedious, isn't it? It doesn't end here. Next time would be 3. Now we are starting with 4. It will be 4 into 5 up to 100. Will we sit and find the sum of each of them? Right? And it goes up to 100, so it's quite lengthy. Right? This would be the manual approach, right? Just adding the sums. Okay. You may not know, so it's okay. One thing, do we know what is summation alpha now? Do we know what is summation alpha? In general, when I say summation alpha, what is mean? No. Okay. Let me give a better example. So let me say a plus b whole square. This we know, right? What is a plus b whole square? Right? So this is what? A square plus b square plus 2ab. Fine. That's fine. So what is a plus b plus c whole square? Can anyone tell me?
A square plus b square plus c square plus 2 into ab in 2 into ab plus 2bc plus 2ca.
C. Okay. What about a plus b plus c plus d whole square?
The same thing, but we add d squared and
We add what? So
d
these terms
squared and
okay.
ad ed cd. 2ad bd cd.
Okay, same thing. Plus we add some things. You say what? 2
ad 2
AD,
bd 2 cd.
2 BD, 2 CD. Okay. Do everybody agree with this? Or is everybody sure that we are going to get this? Are there any doubts? If anybody has a doubt, all you have to do is multiply. Right? If you have a doubt, please multiply. There are not many terms. Multiply and check whether it's true or not. So you can see we have AB. We have after AB we have AC. Then we have AD. Then it starts from B, BC, BD. Then it starts from C. Can you see the pattern now? Right? Suppose instead of four terms, if I generalize, right, write this something like A1, A2 up to AN whole square. Can you tell me now what is it? What would it be the sum now? Would it be something like sum of all the squares of A1 up to AN?
Yes, sir.
Yes. So can I write it as summation A, say R square, just to say N is a from 1 to N. Is it fine? Does it convey the same message? Correct? All the square, right? All the squares. Then can I write this as 2 into summation, say AI into AJ? It doesn't matter what I and J are. Again, I and J, say, start from what? 1 to N. Is it fine? Are you able to follow?
Yes, sir.
Basically, what I'm saying is, this is nothing but sum of all the squares, right? Sum of all the squares from A1 to AN, all the squares. This is 2 into sum of product of any two numbers, right? Product of any. That's what we get actually in the whole square. Why am I explaining this? Because if you know that, then this is what we want. See, if I take from 1 to 100, 1 to 100 if I take, okay, this would be summation, say R square, or in this case, all the numbers from 1 to 100, right? 1 to 100. Fine. This is what our problem is. Plus 2 times, this is what we want. Say, let me put a capital X. Is it okay? So what is capital X? This is what we are trying to figure out, the sum. Right? This is okay. Not this. Okay. Yeah. Capital X is sum of first n natural numbers, 100 into 101 by 2 whole square minus summation R square. Do we know what is the sum of square numbers? Did I mention the formula?
No, sir.
Yes. We didn't mention.
No, sir.
Okay, I'll just mention it now. We'll see why it is true and all. Okay, just note it down from now. Summation R square. Summation R we have seen. Summation R is n into n plus 1 by 2. This is sum of the first n natural numbers. Whenever I write summation like this, it's assume for that it is from 1 to n. Okay. Similarly, sum of the square of first n natural numbers is n into n plus 1 into 2n plus 1 divided by 6. Is it okay? So you can apply the formula here if you want. So it is 100 into 101 into 201 by 6 whole divided by 2. Whatever this number comes out to be, that would be the sum of that. Okay. You not worry too much about it, but I'm just saying there would be a method to figure out the sum of this also. Fine. In your higher classes, probably you would require, but I just wanted to give you just to improve your thinking how to get X for 98. You have to think of all the cases at least. Fine. Any doubts here? Wanted to ask something. And this sum is required for 10th standard. I'm not saying you should know this summation. That when you multiply so many different numbers, you're going to get so many terms, right? So many terms, and what are those terms? Those you have to figure out. Okay. Yes. Let's move on. Did we get this? This shouldn't be that difficult. Just quickly, somebody will discuss the solution directly. So SR denotes the sum of our terms. So SM by SN, the sum of m terms divided by sum of n terms is given as m square divided by n square. Okay. So we have to find the ratio of mth term divided by nth term. So what is this? So what do we know about sum? We know the formula m by 2 into 2a plus m minus 1 into d. This should be the sum of first m terms, right? What is n terms? N terms, n by 2, same thing. Instead of m, there's n, that's it. Right? This they are given as m square by n square. We just figure out what we want to find. We want to find a plus m minus 1 into d somehow, right? Divided by a plus n minus 1 into d. This is the nth term, right? This is the nth term of, if you want, you can write it as tm by tn. Okay? This is, so somehow using this, we want to simplify and get what this is, right? That's the goal. Let's see. So this 2 will get cancelled, right? Both. You can see one of the m and one of the n also will get cancelled because they are on the same side, right? So you can cancel out. Both are not 0. If both are 0, there won't be anything to solve here. One of the terms is 0. So we'll cross multiply now. Now n into 2a plus md minus d. I'm just multiplying the terms inside.
Sir, how did the m and n get cancelled? I'm not clear about that.
So divide both sides by m.
Okay, sir.
So one of the m will get cancelled here, right? There's m square, right?
Yes, sir. Okay, sir. Got it, sir.
Okay. So cross multiplying now. So n I have multiplied. So what remains? M remains here. M into 2a plus nd minus d. Multiplying inside 2an plus mnd minus nd equals 2am plus mnd minus md. Right? So one of the term gets cancelled. We'll get the like terms to one side. So n and n we can get, or yeah. So n is already common here. So let me take n. Do we get something? We'll see. If we don't get something, we'll m into 2a minus d. Now see, there are two things here. So for this trivial case here, just imagine if you're saying 0th term of an API, right? There's nothing we are adding, we're not doing. There's no 0th term also. If you assume that n is starting from 1, right? Not figuring out n. Similarly, what is the other case? Look, if this is not if it is not 0, that means it says that m is equal to n. So if these are equal, if m is equal, then we are simply dividing. We are simply dividing Sm by Sm. So obviously this is 1. If you're talking about same term, even Am by Am will be 1, right? There's nothing. It's a trivial case, right? So obviously we don't want any trivial cases. So we're just trying to remove these cases, right? So that means n can't be equal to m for sure. That means 2a should be equal to d. This is the only solution we can have. Are you able to follow? Right? If 2a is equal to d, now you substitute here am by a. 2a is equal to d means what? Okay, you can substitute for d if you like. A plus m minus 1 is into 2a divided by a plus n minus 1 into 2a. What is that equal to? It becomes a plus 2am divided by a plus 2am. Right? A is common throughout, so a into 1 plus 2m divided by a into 1 plus 2m. So this will cancel. So your final answer is 2m plus 1 divided by 2n plus 1. So you can see we got rid of a and d. It's independent of a and d.
Sir, it will be 2m minus 1 by 2n. 2m
So
minus
it'll be
1 by
minus
2n.
a and
Because
minus a.
My mistake. Yeah. We'll try to. Okay, let me just simplify from here so that there's no confusion. So we have this term is 2am minus a. So this is minus 2a plus a. So it's minus a. Similarly, 2an minus a. So a is common in numerator and denominator. So it's 2m minus 1 and 2n minus 1. Okay. So a and a will get cancelled. We have 2m minus 1 by 2n minus 1. Right? In doubts here. Now, see, why should we approach like this? See, we usually are used to having formula and answers. This is not how it will go, right? For these involved problems, you have to try with whatever information is given. This is the information given. You work with it, right? You try to simplify. You try to cross multiply everything what you can, right? From there, you look at whether you can get some more information. Then to try to apply that what is asked. Somehow some simplification is there. Here there will be some terms which will relate to here and you'll get your answer. Okay. Okay, next. I think that's almost time. Oh, there are 2 more problems. I thought of completing GP2. It's not started. Yes. Did you get the answer for this one? The above real numbers that belong to arithmetic are in order. Find the next term of the sequence. Equate the differences. Okay, let's try it. So it's in arithmetic progression. That means here the common difference should be the same. That means AB minus A by B should be equal to what is the other difference? A minus B minus AB. Correct? Suppose this is A1, A2, A3, and A4. Fine. So now this is A2 minus A1, what I've written down. This is A3 minus A2. Similarly, I'll write A4 minus A3 because the common difference should be the same. So it is A4 minus A3 means A plus B minus A minus B. I hope everybody is able to follow. Right? So we're just using the property. They have given it as arithmetic progression. We're just using one of the properties. Let's see. I think this last simplifies very easily. So A plus B, A minus B. A and A will get cancelled. This will be equal to 2B. Right? Okay. So 2B should be equal to every term. So even this term I can equate to 2B. Anything I want I can equate to 2B, right? Right? Because that is the common difference now. The common difference will become 2B. Right? All of this is equal to D, right? So common difference should be same. Okay, let me equate to this. Let me see. So A minus AB is equal to 3B, getting the B other side. A is common. So 3B. So A I got in terms of B. That is the goal. Right? I wrote A in terms of B. Now I have one more equation. See, I've used this to get 2B. Then I equated this to this. Now only thing remaining is this to this, right? That should solve it. So what do we have? So AB minus A by B. This is also equal to 2. Right? Again, A is common. B minus 1 by B is equal to 2. Do we know what is A already is? We already solved for A. We already got what A is. We substitute in this equation. 3B by 1 minus B. Here we'll take the LCM. B square minus 1 is equal to 2B. Assuming B is not equal to 0. Because if B is 0, I think most of the terms, see here it's not defined at all. So B certainly can't be equal to 0 for the first term. You can see that. And it's an AP. You can't get infinity in an AP. Anyways, so that gets cancelled here. I'll take this 3 to the other side. It will be 2 by 3 here. I'll factorize the numerator B minus 1 into B plus 1. Right? A square minus B square. Why did I factorize? Because you can see that denominator is B into 1 minus B. So you can see this will get cancelled with a minus 1. Or basically you take a minus outside and they'll get cancelled. Again, one more condition. If I'm cancelling, B cannot be equal to 1. That is the second condition. Or if b is equal to 1, you have to take a separate case and figure out. Okay. Now, what remains? So b plus 1 by b, this minus sign taking to the other side is 2 by 3. Just solve this. This is 1 plus 1 by b is minus 2 by 3. Or 1 plus 2 by 3 is 1 by b. Or that implies what? 5 by 3 is b. Or b is 3 by 5. You got b. All you have to do is find out a. So a is already we have.
B will be minus 3 because 1 plus 2 by 3 will be minus 1 by b.
Yeah, minus 1.
Sir, while transposing, I think we have switched the negatives. The last is
Okay, sorry. It's a minus 1 by b, right? It's minus 1 by b. Yeah. So, okay, let me just correct it. So 1 plus 2 by 3 is minus 1 by b, getting this here and the other term. Yeah. So b is what? B is 5 by 3 into a minus sign. So let me write first. This is 5 by 3 minus, so it's plus 1 by b, multiplying into minus. So b is minus 3 by 5. Is it fine? Right? So again, substituting here in a, because we already have formula. So 3 into minus 3 by 5 by 1 minus of minus 3 by 5. So it will be plus. So this is what? Minus 9 by 5 divided by 8 by 5. Or a is minus 9 by 8. So we got a, we got b. I think all the terms are belong to. Find the next term of the sequence. So for next term, we first have to figure out what is a plus b. No? A plus b. We'll write. What is a? A is here, minus 9 by 8. What is b? Minus 3 by 5. This, to get the next term, it is a plus b plus 2b, isn't it? Because common difference was 2b, we got common difference as 2b. Correct? So all we have to do is find a plus 3b. Instead of adding 2b later, I'll directly add and try to figure out. Okay. So this is what? So minus 9 by 8, 3 into 3, minus 9 by 5. Right? Now LCM, if you want, you can take minus 9 common, 1 by 8 plus 1 by 5. Easier to take LCM, that's all. So minus 9, so it is 8 plus 5, 13 divided by 40. See, not a standard number, right? So we are getting some different, okay. But you get used to it. Not always you get a good integer, so on. So 9 into 13, so 170. So this should be your next term. Anybody got the same answer while solving?
I got it.
Yeah, same answer, right? Okay, so we're right. Okay. Is it fine? See, this is one of the difficult problems, right? So again, it comes in Olympiads and stuff like that. So we just follow what is given. Right? We simply followed the simple rule that the common difference is D, right? Common difference is D. We got this, we equated it. We equated to the previous term. Then we equated to this term. Just by doing that, it was lengthy, but the concept was the same. Nothing else. There was no new concept in there. Right? It was lengthy, but no new concept in there. Were you able to understand what the problem was? Or the problem was not difficult to understand? If it's difficult, please tell. Others, I won't figure out, right? So look at, there's a sequence A1 to A1. Okay, it says that it satisfies these conditions. What is that condition? A1 is 0. The first term is 0 in this sequence. First term is 0. Second term, that is, instead of giving the term directly, they have given some relation. So it's mod of A1. A1 is already known, it's 0. Fine. So what does A2 equal to? See, A2 is nothing but mod of 2 or minus 2, but which is 2 itself. Right? So 2 or minus 2, it doesn't make a difference because it's inside the mod. So what does this mean? Mod of A2 is equal to 2 means what? What is A2?
Minus 2 or 2.
Yeah.
Minus,
Minus.
sure, no?
Yes, sir.
Yeah. A2 can be 2 or it can be minus 2. Both ways, I will get the mod as 2. Right? So we are saying A1 is 0. A2 can be 2 or minus 2. Either way it's possible. Then there is another relation. A3, they're saying mod of A3 is equal to A2 minus 2 mod of this. Now the problem starts. Now you're saying A2 is 2. If A2 is 2, now let me assume this first case. If A2 is 2, A2 is 2, this is 0. Mod of A3 is 0. What do you mean by mod of A3 being 0?
A3 is 0.
A3 is 0.
Other number, right? Only one number I'm getting, correct?
Yes.
Suppose A3 instead of 0. A2 we have taken as plus 2. I'll take it as minus 2. Right? If I take minus 2, this is 4, correct?
Yes, sir.
So what is A3 equal to?
Minus 4.
Minus or plus 4.
Minus 4 or plus 4, two solutions again. So look at this. If I take minus 2, I can either get 4 or I can get minus 4. Fine? Agreed? I'm just trying to write down the solution, looking at the pattern. Okay.
Yes.
Okay. So let's continue. I hope this is clear. So now we are at A3. They say this is pattern continuous for all numbers. So an, take any an, have to use this to get use an minus term to get an, right? So now I'm talking about A4 then. Mod of A4 is nothing but mod of A3 minus 2. Fine. Now look at the values of A3. A3, if it was 0, I think we are getting back to this. Can you see that? We're going back to here one step. Right? There won't be any difference, right? If A3 is 0, that means I'm going back here. So this is 0, so this will be 2. So next case will be 2 or minus 2. Isn't it? You able to follow?
Yes, sir.
Okay.
Yes,
Okay.
sir.
So I'll simply write 0 to. I can continue this. Instead of 2, I can have minus 2. I'm not denying it. But if I'm going to minus 2, I'll come to this path. Right? I hope you can see it. Okay. So I'll ignore those obvious cases. I'll just check for these cases. These are new cases, 4 and minus 4. They were not there before. Okay. So what will happen if I take it as plus 4? Plus 4 means this will be 2. So again, plus 4 means this can be either 2 or minus 2. Can you see again it's going back somehow? The same case. Right? Suppose I get minus 4. So mod of A4 will be minus 4 minus 2, which is mod 6, or which is 6. Or A4 is plus 6 or minus 6. This is for what? Minus 4. So minus 4 can be plus 6 or minus 6. Can you see a pattern? Can you see a pattern? What we can get? Huh? See, so it's 0, 2. You can continue like this. It's fine. Okay. So I can either oscillate between 0 and 2 only, right? Every time I choose this number, right? First I choose 0. First 0 is fixed. Next I choose 2, plus 2. Again I'll get 0. So again I choose plus 2. I'll go back to the same pattern. Fine. So instead of choosing plus 2 here, what if I choose minus 2? That is the second case, right? Instead of 2, I go for minus 2. Now I get one more case. Instead of 4, I get 4 and minus 4. The previous choosing, let it be same. It doesn't matter. I can get 4 or minus 2. So if I choose 4, we have seen that I get 2. I get 2 or minus 2. It's same as going back, right? For example, if I take 2, I'll get either 0 or 4. Can you see that? Sorry. If I take 2, it's always 0. If I take 2, it's always 0. Right? If I take minus 2 instead of 2, if I take minus 2, Minus 2 either can give me 4 or minus 4. That's only two cases we have. I don't know, it's difficult for you to get it in the first time. Right? Just try it again. It's a very, very involved problem. One of the probably for your level it would be an Olympiad problem, right? But for higher school, because they have learned more of this. So see, this is minus 6. We said it can be minus 6 or 6. So the pattern continues. See, if I take plus 6, I'll show you. So if I take minus 6, so this is another case. This is minus 6. Okay. So minus 6. For 6, if I take, just look at the next number, what will happen? A5. If I take the positive number, always it will get reduced. It will get reduced, right? It will be 4 or minus 4. Fine. It will get reduced. So either I can choose this pattern. You can see it can keep on increasing like this. So I just want you to see what are the different possible cases. See, after 4, I can go back to 2. I can go back to 0, and I can continue to 0, something like this. Or after 4, instead of going back to 2, right? So I can choose the negative side or minus 2. So minus 2. So I can go back to 4, something like this pattern. So all the pattern will be something repeated before. You won't get any new pattern unless you're going for a higher number. You understood? Now the question is, look at the question. The question doesn't end here. It doesn't say that find a pattern. This is what he simply wrote down the formula and try to analyze the problem. That's it. The question is maximum value of the arithmetic mean of these numbers. So for example, I choose the first pattern. Take the arithmetic mean. What is the arithmetic mean? In this case, you can see the arithmetic mean is equal to 1. What is the arithmetic mean? Sum of the numbers divided by total numbers, right?
Yes, sir.
Yes, sir.
So it doesn't matter. Suppose there are n numbers. So 0 plus 2, 0 plus 2. N numbers divided by n. Okay. What is the numerator? Numerator is also n, right? Because 0 and 2, the sum of two numbers is 2 always. So sum of each two numbers is 2. Total sum will be n. Correct. So mean. So somebody had answered n minus 1 by n. So 1 is already greater than n minus 1 by n. So certainly this can be the one of the greatest answer. Okay. Now we have to see, is this the maximum? See, the question is find the maximum value of arithmetic mean of this. Not any arithmetic mean. There are different patterns we can get. I can choose any pattern I like, but I want to make the mean maximum. That's all the question. Understood? So instead of choosing 2, 0, 0, 0, 2, 0, 2, so on, I can choose minus 2 and take 4, and whatever I want I can do. I can choose minus 5, I can choose 6 and go on. Right? So I choose whichever number. Like obviously it should come from a formula, not random choose. Right? I can't pluck in number, but I can out of 6 and minus 6, it's my choice, right? Choose a number and make it maximum. That's all the question. Now what should I choose? Which one should I choose? So suppose I take all the negative numbers, it won't make any sense, right? It will be a negative number. There is absolutely no use of taking all numbers negative. Correct? You get the idea, right? So obviously some positive number somewhere I should take. There's no, if all are negative, the mean will be negative. So we want the mean to be greater. 1 we already got. If it's greater than 1, okay. Can we get greater than 1? Okay. Let's choose some random pattern. Let's see if we can get. Okay, we'll choose this sequence. We'll try to complete this sequence. Okay, just for you to understand better. Now, one option was using 2 going back to 0. So we didn't want to do that. So what we did, instead of 2, we choose minus 2. Now again we have an option. If I choose 4, I will next number I have to choose 2 or minus 2. No other choice. If I choose 2, it will be 0. Okay. Now let me just check the mean of these 5 numbers. Is it fine? Just to get an idea. Or the 4
Yes.
numbers. If you are repeating the same pattern, I will reduce the mean. Let's not make it. If I am trying to repeat the same pattern, okay, repeat the same pattern, I'll just find the mean of 4 numbers. That will give me the mean of the entire, right? It's always the same. If you're repeating a pattern, you can take the mean of 4 numbers. It's the same always. So 4, this, what is the sum? 0 minus 2 plus 4 plus 2 divided by 4. It's still equal to 1. Mean is still 1. Let's look at some other pattern then. Instead of 4, we'll choose a negative number only. Minus 4. Next number, now we'll choose positive. Okay. We can go for more negative if you like. We'll choose positive. Now again, I have an option. Now, when I choose 6, the next option will be what? It will be 6 minus 2. So it will be mod 4 or 4. So mod of that number will be equal to 4. So I can choose either positive or negative. To increase mean, I should choose positive, right? If I choose negative, you can see that the number will decrease anyways. Okay. So I'll choose positive. Again, to increase, I'll choose 0. I'll make this a pattern. Okay. This one, how many? 6 numbers. After that, it will repeat again. Okay. That it will repeat. Just look at this. Minus 2 minus 4 plus 6. There is 0. Okay. You have to write it down for me. So divided by 6. So you can see these two numbers cancel. So it's 1 again. Can you see if you choose any pattern except from all negative numbers, right? All negative numbers, you will go to the same mean. Obviously, I'm saying if you repeat the pattern. If you don't repeat, it doesn't matter actually, right? So overall, you're doing the same thing. The sum of that set is always equal to that number actually. Sum of whatever you do. See, you go for negative, negative. Whatever positive number you choose will be 2 more than this last negative number. Okay. Then the positive numbers will all cancel with the negative numbers. If you go back to 0, suppose you don't go back to 0. Suppose you choose the number something like this: 0 minus 2 minus 4, 6. Next, you don't choose, okay, you choose 4. You choose 4. Now you don't choose the positive number. You say, I don't want to. I'll take minus 2. Now again, you're decreasing the number, right? You're decreasing the mean. Okay. Now, next again, you have a choice, either 4 or minus 4, whichever you want. You can see the cycle will repeat. Whatever you do, the cycle will repeat from here. There's no way forward. It's a simple problem, but look at the analysis. So much time we are simply analyzing the problem here. Okay. In this case, all the means were same. But a usual problem would be there would be different means. You should choose what is the best one, and you have to give a justification for it. Okay. That's how it will be. Do not worry this for your school exams. No one will ask such questions. Okay, no need justification for such questions. But yeah, the best example would be RMOs, something like that. They would you see sit with the problem, try to analyze it, and then finally. While doing that, your rest of the concepts will improve. That's why I gave such question. There's no other reason. You'll understand mod better. You'll write sequences better. You look at different cases. Even though, see, in the problem, there's nothing new I'm teaching, nothing out of the syllabus or something like that. Problem might be lengthy enough, but concepts are just simple mod. We're using mod and we're trying to figure out what the pattern is. If you want to take more examples in the same, okay, take some more examples, see any pattern, whatever you do, you'll get the mean as 1. Obviously, unless you take entire set of negative numbers, or you don't end with the 0. If you're not going back to 0, what will happen is you'll get a mean less than 1. Okay. Suppose you're saying this pattern can't repeat itself. It should either end to 0 or keep on increasing or decreasing, right? Something like that. If it's going back to 0, okay, I'm certainly sure I can go back here and repeat my same procedure. So I can find the mean easily. Okay. Any doubts here? Because it was quite lengthy and confusing maybe. So, any particular doubts? Anything is not clear? We need more justification. See, how to start really comes by practice, right? Okay. It is, for example, you had seen the problem, then it'll help. So we have seen arithmetic progression, right? Now we'll see geometric progression, which is commonly called as GP. This is geometric progression. Can you guess what would be the change? So we had seen that we have a common difference, right? So basically, the difference between the consecutive terms or the constant in arithmetic progression. Now, in geometric progression, we would have a common ratio. Okay, instead of common difference, it's a common ratio. And the letter which we use to denote is R. Okay. So what will happen? For example, see the first term is 1. Then I'll multiply a number, for example 3. Then the next number will be 9, then 27, 81, so on. So in the arithmetic progression, what we had is difference was common. Now the ratio, look at the ratio now. 3 by 1, it's 3. 9 by 3 is still 3. 27 by 9. See, because I'm multiplying the same number, right? So I multiply by 3 to get this sequence. You can see that, right? Right? So obviously, if I divide these two, I'll get the number 3 itself. If I divide any two, I'll get 3 itself. Suppose I skip a number. If I divide 81 by 9, I'm going to get 3 square, because twice I'm going to get. So suppose my first term, we'll keep it as it is, A, right? First term is A. Then what would be my next term? Because I said common ratio. A, TA. What is T? T is
3A.
3A. Okay. If my common ratio is 3, you're right, 3A, right? But what if my common ratio is R?
RA.
RA, right? A into R. What would be the next term?
AR square.
AR square. What would be the general term? For example, nth term, AN. Nth term, what would be AN equal? Okay.
AR n power minus 1.
AR n power minus 1, correct. See, what would be the 10th term? You could guess, right? 10th term would be A into R power 9. That would be your guess, correct? See, first term didn't have R, correct? Second term had R. Third term had R square. So 1 less, correct? So 10th term would have 1 less. A into R power 9. In general, nth term would be A into R power n minus 1. Clear? Simple, right? Nothing much. So this is a sequence. Okay. Finding out the terms is easy, right? Anybody gives you a GPS, you will simply apply the formula. Yes, this is the term. That's it. But when you try to find the sum, that's when it gets complicated. So Sn, again, there is Sn for sum of n terms here, right? So we are trying to find the sum of all this AR square up to AR power n minus 1. Look at this approach. This is very useful actually. Okay. So what we do, again, we write Sn. I think this sort of we have used for AP also. Okay, in one of the approaches. So now look at this. Instead of writing Sn directly, what I'm going to do, I'm going to multiply with R and write. The same terms, I'm going to multiply with R. So what would be the first term? AR, correct? I'm just writing it, shifting 1, because I'm going to subtract. So while subtracting, these terms will get cancelled, right? That's the reason I'm shifting and writing. So next term would be what? AR square. Next would be AR cube. And here I would have a term AR power n minus 1. But the last term would be AR power n, because I'm multiplying with multiplying with R. So this into R would give me this term. Is that fine? Now I'll simply subtract these two. Okay. Direct subtract. So look at this. All this sign will change, right? So here it will. So Sn minus R into Sn. This is on the left hand side. Fine. right hand side, this is 0 here, this is no term. So a minus 0 will remain, right? As a itself. Next term would be cancel. Again, AR minus AR square, AR cube minus AR. So even here, up to these terms, you can see all the terms are getting cancelled. What is the only term remaining? Here it was 0. So 0 minus this, so AR over N. You see all of the terms are getting cancelled. Only two terms remain. Why two terms remain? See, A term is remaining because I multiply with R, so the first term changed to AR. And this term is remaining in this sequence, I multiply with R, so one extra term. So the first term here and the last term here is remaining. That's it. Okay. Now what is Sn? You can see that Sn is common. It's 1 minus R into A. Here also you can take R common, sorry, A common. So R power N. So Sn is A into 1 minus R power N whole divided by 1 minus R. Is it fine? This is the sum of intervals. Not only that, this approach is important. Not only this derivation. Why I'll tell you later. For GP only you may not require this because you can't remember the formula. But I'm going to give you another sequence later, right? It's called as AGP. Okay, I won't do the theory, but directly give you the problem where you can use the similar approach to get your answer. Okay, fine. So the sum we know, any nth term given, we know how to find. We know how to find the sum. Okay, so we'll solve a couple of problems, then we'll come back to more theory. Fine. Yes. Simple direct problem. What is the 10th term of this sequence? Tanmay, can you answer?
Sure,
Yes, Tanmay?
sir, still seeing, sir, like solving.
Yeah, tell me what for the 10th term, what do you need?
Don't know, sir.
Don't know the formula. Just now you have seen the formula, right? For nth term. What is the formula for nth term? Not listening to the class, huh?
No, sir.
Okay. En was a into r power n minus 1 for geometric series. So for this 10th term, it would be a into r power 9. 10 minus 1 is 9. So a is 1 in this problem. R is 3. So 3 power 9 is the answer. That's it. You do not multiply now. You keep it as it is. That's it. Direct application of formula. Okay.
Yes, sir.
Fine. Can you answer?
Yes, sir.
Yeah.
So the second term will be a into r to the power n minus 1 is equal to 4.
So a into r power n minus 1. So 2 minus 1, right? It's 1 itself, right?
Yes, sir.
Okay. Fifth term.
Yeah, so a into r to the power 4 is equal to 1 by 16.
Yes.
So then we divide the second equation by the first one.
Okay, divide the second equation by the first one. So I divide 2 by 1. So I'm going to get 1 by 16. On the other side, I'm just dividing. It's 4. Here, if I divide, it's AR power 4 divided by AR. So A and A will cancel. This is R power 4 minus 1. This is R cube. This is 1 by 64. So R is what? 1 by 4?
Yes, sir.
Okay. So we want the 9th term, right? So we want T9, which is A into R power 9 minus 1, R power 8. So A is what? A, we didn't find out what is A. Okay, okay. We have to
A
do
will be
that.
16.
Yeah, AR is 4. We have we can substitute in any of the equation, right? So AR is 4. So A is nothing but 4 by R. So R is 1 by 4. So A is 16. So 9 will be 16 into r power 8. So 1 by 4 whole power 8. You can keep it as it is. So in GPs, these terms will be very big, so you do not multiply all these things. Okay? You can keep in terms of power, not an issue.
So for finding R, we could just substitute AR in AR power 2.
TR to find R, sorry, I couldn't follow.
To find R, like we could substitute T2 and T5.
To find R, we could have substituted T1 in T5, you mean?
Yes.
Yeah, we would get the same thing. Okay, that's what you can use any equation. This is easier, right? That's why I used first one. That's it. You use the second one, still you'll get the same answer. Okay?
Yes.
So you can just change the power here if you like. This is 4 square, and this is 1 by 4 whole power 8. Just to write the simplified version, you can write 1 by 4 whole power 6. Right? You can simplify that way if you like, but you not find what is 4 power 6 and so on. Okay. Fine. Okay, Karthik, what is this? Tell me, what is the summation of?
Yeah, we can find, you can use the formula.
Okay. So if we expand this, what we get? We're getting 2, right? 2 is the first term.
Yeah. 2 plus 2 squared plus 2 power 3 plus 2 power 4.
Okay, up to 2 power 10, right?
Yeah.
Okay. So you're using this formula for Sn, sum of n terms, which is a into 1 minus r power n by 1 minus r, fine?
1 minus r.
So a is 2. This is
Yes.
2 power 10 divided by 1 minus 2. It's negative. So I can just write 2 into, okay, let me just write it down. 1 minus 2 power
2 power 10 minus 1.
Minus 1, right? So minus I'll multiply inside above. So it is 2 power 10 minus 1, fine? Or 2 power 11 minus 2. If you want, you can expand. It's not required because it's not that. This is 2048.
Yeah.
You know that. 2 minus 2 is 2046. Remember one thing, this formula, somewhere you can find it something like this. A into r power n minus 1 to r minus 1. It doesn't make a difference. You just multiply with a minus sign to the numerator and denominator. Okay. What happens usually for these problems, r will be greater than 1. So you do not multiply with a minus sign. That's all. Okay. It really doesn't make a difference. Okay. You can remember the same. Fine. So do not worry about it. Okay. I hope it's clear. Okay. For the battery code, I just want to complete the problem. Close there. Third term is 4. Fine. Third term is 4. Product of the first 5 terms. I think a similar concept was used in arithmetic progression, right? I think 3 terms we had taken. We had taken as a minus d, a and a plus d, something like that. Right? So here, look at this. This is GP now. Again, you can take this. That's why they give the third term or the middle term always. You can instead of taking the terms as ar square. It's not that you can't solve. You can solve, but we can do it in a better way. That's it. So these are the terms you can say. It's in GP. Or look at this. You can take middle term as a. This will be ar. This will be ar square. Right? We are multiplying with r. Right? Other side, what should be? It should be a by r. Correct. We are multiplying with r and getting a. And this should be a by r square. So by multiplying with r, I should get the other term. Fine. I hope it's clear. What's the advantage? Just try to find the product of these 5 terms. See, if you try to find the product, a by r square and ar square, so this will get cancelled. A by r into ar, this will get cancelled. There's one more a. So total is a power 5, which is what we have to find. And we know what is a. It's given that a is equal to 4. So a power 5 is nothing but 4 power 5. Right? I hope it's clear.